So last thing we'll look at for this one is law of cosines. So we've already been using law of sines to solve triangles. And can someone remind me what is one of the three kinds of problems that you can use law of sines for? Yep, SSA. That's the trickiest one because you got to deal with the no solution, one solution, two solution. But that is one type. What's another type that we use law of sines for?
Angle, side, angle.
Yep, angle, side, angle. Okay, that's one of the easier types because we always are given two angles, a side between them, and you always have one solution. You never have to worry about anything else. And there's one more type that falls under law of sines.
SAA.
What is it?
SAA.
SAA. Yep. SAA, or you could say AAS, same thing. Angle, angle, side, side, angle, angle. That's very similar to this one above it. You always have one solution. Never have to worry about the two solution or no solution. So those are the three kinds of problems that we've done with law of sines. Now we're going to look at law of cosines. So law of cosines allows us to solve two other types. Anybody think they could give me one of the two other types that's not on the board?
Side, angle, side.
Yep, side angle side is one. With side angle side, you never have to worry about two solution or no solution. It's always going to be one. And there's one more type.
Side, side, side.
Yep, knowing all three sides. Now, with all three sides, you can never have two solution, but you could have a no solution. We're never going to do any that are no solution. Right? So for our purposes, side, side, side will always have one solution. All right. So we're going to take a look at what the law of cosines is, and then we'll try an example of each type. So we're not going to solve this right away. This is going to be our first example, but I just want to take a look at it and see what would happen if we tried to use law of sines. When we use law of sines, how many rows at the table do you need to use? Two. You always have to pick two rows. And when you pick two rows, there can only be one thing that you don't know between the two rows. Let's say we tried picking the first two rows. If you pick the first two rows, how many things are unknown altogether in the first two rows? Two. Okay, that's not going to work. Okay, we can't do that. So then let's try picking two different rows. Let's try the bottom two. If we pick the bottom two rows, how many things are there that we don't know? Still two. All right. The only other combination we could try is the first row with the last row. If you do the first and the last row, how many things are there that you don't know? Still two. So no matter which combination of rows you pick, you're always going to have two things that you don't know. You're not going to be able to solve that with law of sines. Okay. This is an example of what a side, angle, side pattern looks like when you put it in a table. You will never have a complete row. And side, 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 you'd have the same problem. You'd know all three sides. No matter which two rows you pick, you'd always have two things you don't know. So the law of cosines is going to be used to solve the two kinds of problems we just wrote down on the other page. So that is part of what you're going to have to figure out tomorrow on the test. All right, all the problems are going to be mixed up for everybody. So you're going to have to first figure out, is the problem law of sines or is it law of cosines? And then go from there. On the left is an example of a side angle side triangle. What makes it side angle side is you know two sides and you know the angle where the two sides meet. You know the angle that's between the two sides. The one on the right, that's side, side, side. And what makes it side, side, side is you know all three sides. So what always has to happen in a side, side, side triangle, or any triangle, any two sides added together have to be bigger than the third. That's what always has to happen. I will always give you a side, side, side problem where that happens. So you're not going to have to worry about a no solution with side, side, side. So if you check this, 10 plus 7 is bigger than 6. 10 plus 6 is bigger than 7. And 7 plus 6 is bigger than 10. So yes, any two sides added together there are bigger than the third. For our purposes, it always will be. So let's look at what the law of cosines is. The law uses the same variables we're already used to. A, B, and C are going to represent sides. Alpha, beta, and gamma will represent angles. And the law starts off like that. That's not the whole thing, but that's what it starts as. Does that look similar to anything that we've used before? Right, it looks kind of like Pythagorean theorem, and that's what the law of cosines is based on. It's based off the Pythagorean theorem. But we know the Pythagorean theorem only works on what kind of triangle?
Right.
Right, yeah. It only works if you have a 90. The triangles that we're going to be doing don't have a 90. So it starts out like the Pythagorean theorem, but then there's this adjustment we're going to subtract. And what this does is it allows us to basically use the Pythagorean theorem on any kind of triangle. And when you use it on any kind of triangle, then they call it the law of cosines. Okay, so let me read to you the formula, but I'm going to read it. Let me just fix my gamma. I'm going to read it more as a pattern than actual letters. So the pattern for the law of cosines is one side squared, any side, one side squared equals the sum of the other two squared minus twice the product of the other two times the cosine of the angle across from the side you started with. That's the pattern. And the reason I wanted to read it that way is because you can start the formula with any letter that you want. Okay. The important thing is we just use exactly the same pattern. One side squared equals the sum of the other two squared minus twice the product of the other two times the cosine of the angle across from the side you started with. Okay. So anyone think they know what's going to come after b squared?
A squared.
A squared
A squared is c squared.
plus c squared. Yep.
Minus 2ac.
Minus 2ac.
Cosine. So we get.
And what's the last part?
Cosine gamma.
That's we already used gamma up at the top.
Beta.
Beta. Yep. Cosine beta. Okay. So that's not a different formula. It's the same formula. It's just been rearranged using different letters. Okay. And how about the last version? Anyone think they could tell me what the rest of the formula would be there?
B squared plus C squared minus 2.
So say it again. A squared equals.
B squared plus C squared.
Yep.
Minus parentheses 2BC
2bc
cos alpha.
cosine alpha. Yep. And if you wrote it with calling the sides x, y, and z, you could write three more versions. X squared equals y squared plus z squared, right? It's not important what we're calling the sides. It's just a pattern that we plug everything into. Okay, so that's the law of cosines. And with the law of cosines, we use it there's two ways you can use it. You're either going to use it to find a side, or you're going to use it to find an angle. And that's it. So let's go back to that first question we had. So same problem, except now we're gonna try to solve it. Okay, we've already gone through the reason why you can't use law of sines. All right. You don't have a full row. Okay. No full row, no law of sines. So we're gonna use law of cosines. Now, we've got to pick one of these versions. They're all the same formula, just different versions. We've got to pick one of them to use on that problem. Whatever version we pick, you have to be able to plug in everything that's there into the formula. There has to be space for A, B, and gamma. So what version of the law of cosines would we use that has spaces for all three things?
Number 1.
Yep, you got to use version 1. Okay, you're already missing C. We don't know what C is right now, so that means you're already missing a letter in every formula. Okay, you're missing something in every single formula. If we tried to use version 2 or 3, well, we don't know beta and we don't know alpha. That would be a problem because we don't know the C and we don't know the beta. This formula doesn't work if there's two things missing. Okay, it can only be one thing. So we're going to fill everything in. I'm going to square some things as we go so we can save a little bit of writing. Let's see what happens. So we've got C squared equals, next thing is A squared. What's A squared in this problem? 4. Plus, next thing is B squared. Okay, what's B squared? 9. Minus, now we need 2 times A times B, right? What's 2 times 2?
4.
Times 3?
12.
12. So we have 12, it's 2 times A times B, times the cosine of 60. Okay, so what we're solving for this time is a side. Okay, we're trying to find side C. And anytime that you do a law of cosines problem, if it is side angle side, which this one is, you have to find the side you're missing first. All right. What can we do on the right side now? All right, what would you simplify?
4 and 9 minus 12, just make that 1.
No, we can't do 4 plus 9 minus 12 on the right side. Why can't we do 4 plus 9 minus 12? The 12 is what? The 12 is being multiplied by the cosine of 60. So that's not really going to be a 12. It's going to be whatever 12 times cosine 60 is. We can do the 4 plus 9. Yep. So we can add those together. 4 plus 9 is 13. Minus 12 cosine 60. Now there's nothing else I can do on the right-hand side unless I want to start rounding. Okay, I don't really want to round. So what I want to do now is just get C by itself. Okay. C is not by itself because it has an exponent of 2. What are we going to do on both sides to get rid of the exponent of 2? Yep, we're going to take the square root. So C is the square root of all of that. And that's what I'm going to type in on the calculator to get C. So notice I've done no rounding yet. Okay, I'm about to round, but I have not done any rounding yet. Okay. Any questions how we got to that step? Now make sure when you type it in, everything should be underneath that root. 13 minus 12 cosine 60. So for C, I get about 2.646. 2.646. And I'm going to show you how to do something that is going to keep our answer pretty accurate. We're going to save that answer. right? We're going to save all the decimals that are with it. Right? So I don't know if we've done this yet, but I'm going to show you how to do it. Okay. To save that answer in the calculator, we're going to press the button right above on that says STO. Okay, stands for store. When you press store, if you didn't type in anything yourself, it's going to take the last thing that was on the screen and it's going to store it. Now we just have to tell the calculator where we want to store it. We can store in any letter of the alphabet on the calculator. So we have 26 different places we can store things. I think it would make sense to store this in C. So we're going to store that number in the letter C. To get the letter C on the calculator, it's if you go to the third column from the left, third button down, you'll see a green C. To get the green C, press alpha, and now it's going to use the green buttons. C. So I've told the calculator to take that number and save it in the letter C. Hit enter, and now it's in the letter C. It'll stay in the letter C forever, okay, until we turn the, even when you turn the calculator off, it still stays there. Okay? If you want to check what's in that letter, you can press alpha, you can press C, hit enter, and it'll tell you what you have saved there. If you use a different letter, most of the time, all the letters have a 0 in them until you use them. Okay, so pretty much every other letter on the calculator has a 0 saved right now in it, unless you put something in it. Okay. Any question on how I saved that in C? So that's going to use every single decimal place in our calculations now. Even though I rounded it here, that's fine. I'm never going to use 2.646. I'm going to use 2.6457, and it keeps going. All right, so we've got C, and we saved it. Once you have all three sides, you can find any angle you want. So let's do alpha. Okay, so now we're using version 3. Let's start with a squared. Okay, what's a squared in this case? 4 equals b squared. What's b squared? 9 plus c squared. Okay, this is how I'm going to do c squared. C squared, just like that. And I get exactly 7. So c squared is 7. Watch what would happen if you took 2.646 and squared it. You wouldn't get exactly 7. 2.646. You get 7.001. That's not really the answer. It got messed up because we rounded. Right, you all set?
Yeah, I didn't finish. I have a couple questions left, so can I do them at the beginning of class?
Yeah.
Okay.
Yep. Okay. So any question on why I use the C on the calculator and not 2.646? A little bit more accurate. All right, and we get a much nicer number. I don't have to work with a decimal. I'm not saying you can always avoid decimals, but this time I did. So a squared, b squared, c squared minus 2 times b times c. Well, what's 2 times b? 6. And now I need to do 6 times c. So I'm going to do that on the calculator. 6 times c. And that gives me 15.875. Okay, so that's 2bc. And the last thing I need is cosine alpha, but I don't know alpha. That's what I'm trying to find. Okay, so this equation is very different from the one we had up there. Okay, the difference is up here we were solving for a side, here we're solving for an angle. Okay. All right, what could I do first on the right-hand side?
Combine the two.
7.
Yep, we can add 9 and 7. And what does that give me?
16.
Yep, 16. Now, can I do 16 minus the 15?
No.
No, because that 15 is multiplied by the cosine alpha. So the only thing now is we've got to put the 16 on the other side. Okay. What we're solving now, just if I kind of simplified it a little, basically looks like this. You're trying to get x by itself. So you're going to get rid of the 16 and then get rid of the 15. And what you would do to solve this is exactly the same steps to solve that. Okay. So what would be our next step?
Not the 16 for both sides.
Yep, so we're going to minus the 16. So that's gone. And 4 minus 16 is going to give me negative 12. All right. So now we have two things left to get rid of, the negative 15 and the cosine. We would start with the negative 15. How would we get rid of that?
Divide it out.
Yep, and what would you divide by?
Negative 15.
So divide by the negative 15, 875 on both sides. That's going to cancel your negatives here, the 15s, and it's going to cancel your negatives there. Now, we're not going to do 12 divided by 15.875. We're going to leave it the way it is. Why do you think I'm not going to do that out?
Be a very long decimal.
Because it would be a decimal. Okay, I already have a decimal, and it's an accurate decimal because the way I did things on the calculator, but I don't want to round this because the more rounding I do, the worse the answer is going to get. So just leave it. Okay, so now we've got one thing left to get rid of, and that's the cosine function. How do we get rid of cosine?
Inverse.
Yep, inverse cosine. So take the inverse cosine of what's on the left and what's on the right. Inverse and regular cosine cancel. Okay, quick thing you should always look at the number in the bottom. If it's not bigger than the number in the top, we're going to have an issue. Okay, so the number in the bottom should be bigger. If you forget that and you try to type it in, you're going to get an error. And if you get an error when you're doing law of cosines, you've made a mistake. Okay? Because I told you you're not going to have any law of cosines problems that are no solution. Okay, so inverse cosine. 12 divided by 15.875. So for alpha, we get 40.895. All right, now that we've got 2 out of 3 of the angles, how could we get the third one? Yep.
Add them together and then subtract that by 180.
Yep. So you can add them up and subtract from 180, or you can just subtract each one of them from 180 one at a time, and it's just less typing for me to do it that way. So that gives me 79.105. Okay, so the way that we did that was very accurate because we saved it in the calculator. So everyone should pretty much be getting exactly what we had right there. If you got an answer of like 78.105, unless you show me work with it, you're not going to get any credit for that. Some people send their work so I can look at it. If you had all the right work, but then you did the rounding wrong, you'd lose a little bit of points, but you'd still get some credit. Okay. But so if you had like 75.106, yeah, I would accept that. Or 75.104, yeah, that's okay. You can't 79.5. No, that's too far off. Okay, so that's a side angle side law. Any questions on that one? And let's look at this one. From the table, this one's pretty straightforward to tell the type. What type of triangle is this one?
Side, side, side.
Yeah, side, side, side. We know all the sides. Okay. Do we have a row that is complete? Since we don't have a row that's complete, that means we have to use what formula?
Law of cosine.
Have to use law of cosines. Okay. What's a little bit different about this one and the last one is when we did law of cosines last time, we had to do it twice. Once to find a side, once to find an angle. You're not going to have to find any sides this time. You're still going to have to do law of cosines twice. But when you do it the first time, you're going to be finding an angle. When you do it the second time, you're going to be finding an angle. So you're basically going to be doing the same type of thing twice. Also, when you know all three sides, you can find any angle that you want. So you can go back and look at your different versions for law of cosines. You know the A, the B, and the C. So you know everything in all of those formulas right up to the green line. You know the A, the B, and the C. Okay, we've already found alpha. Okay, so we already practiced doing it that way. Let's try beta or gamma. Which one do you want to find?
Beta.
Beta?
Sure.
Okay, so we're going to find beta. First thing I want to do is write down the law of cosines that has beta in it. How does the formula start that has beta in it?
B squared
Okay, so b squared
equals A squared plus C squared minus 2AC cosine beta.
Yeah, perfect. And now we're going to fill everything in. And they've given us all the sides, no decimals. So that's going to make the arithmetic a little bit easier for us to do. We're not going to have to store anything in the calculator this time. I'm going to be able to write down exact answers right up until I round at the very end. Okay. What's b squared? 9. A squared? 16. And c squared? 36. 2 times a times c. What's 2 times 4? 8 times 6? 48. Already a lot nicer looking equation numbers-wise than we had last time. Okay, next thing that I can do on the right-hand side?
Add 16 and 36.
Yep, add 16 and 36. And what does 16 plus 36 give me?
52.
52. All right, so now we've got that. Remember, you cannot do 52 minus 48. Doesn't work. So what do we do at the next step?
Minus 52.
Minus 52. That's gone. Type that in. 9 minus 52, negative 43. Okay, and we've got 2 steps left. Let's see if we can do both at the same time. What would be the second to last step to get beta by itself? Yep, divide by the negative 48. So that's going to cancel it from the right. And it's also going to cancel my negatives on the left. So I'm going to divide by the negative 48. And one more thing I have to do to get beta by itself.
Inverse.
inverse cosine. There you go. So we did combine 2 steps into one in that last one, but is there any questions on how I did that? Okay, so let's find what that comes out to. Inverse cosine of 43 over 48. Up until this point, there's been no rounding. Okay, so I know that is as exact as I can be. Now I'll round it. I'm never going to need to use this number again, so I don't need to save it. Right? I'm going to write it down, but I don't need it again. So it's 26.384. So that's beta. Now we have to do law of cosines one more time. Pretty much exactly what we just did to find gamma. Okay. Well, or we could do alpha, but we did alpha on another problem, so let's do gamma. Okay. How does the arrangement of letters look for law of cosines in the version that has gamma?
C squared equals C squared plus B squared minus 2
Cosine gamma. Okay, and now we fill it all in. So C squared, 36, A squared, 16, B squared, 9. 2 times A times B. Okay. What's 2 times A? 8. And what's 8 times B? 8 times 3. 24. 24 cosine gamma. Okay, next up. 16 plus 9, which is 25. Okay, that's good. Minus the 25. And 36 minus 25 gives me 11. All right, so now I got 2 things left I need to get rid of. Divide by the negative 24. Okay, now I have one thing left I need to get rid of. Yep.
The inverse of cosine.
Take the inverse cosine. And there's your answer. So notice I didn't use that 26.384. I didn't need it. I didn't use it for anything that we just did. So when you're doing side, 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 one thing that is nice about it is you can find all the things that you're missing separately. Meaning if you make a mistake on one, it will not necessarily make anything else wrong automatically. So now we need to type that in and make sure you put in the negative. Inverse cosine of 11 divided by negative 24. 117.2, well, it's going to round up, 280. Now, if I wanted the best chance of getting alpha correct and not relying on anything that I've already done, I would do this a third time. I could do law of cosines one more time. I wouldn't need anything that I've calculated. I would just use the 3 sides that I was given, and it would start out with a squared. But if I'm pretty confident I got these 2 right, what could I do that would be faster to get the third angle? I could just minus them from 180, so it's faster, but the downside is if you got one of those wrong, and now you're using it to get the third angle, you're going to get the third angle wrong automatically. So 180 minus 117, 280, minus 26, 384. Okay, so 36.336. So again, if you get 36.337, 338, that would be okay. If you had 36.9, you lose some points for rounding at a minimum. You'd lose all credit if you didn't have any work to with your answer. Any questions on that? All right, so that's a side angle side and a side side side. All right, so the last one we're going to look at is finding the distance between 2 points in a word problem, and it's going to use law of cosines. Okay, so the idea of what's happening here is there's a house in front of a surveyor, and they're trying to measure the distance from a point on one side of the house to a point on the other side of the house. You could do the same kind of thing if you had a lake. And you'd probably have to do this if you didn't have a boat, because you wouldn't be able to use a tape measure in a little lake you can't swim with a tape measure really that easy. So you could just survey the property and find the length of the lake. Okay? As long as you know 2 points on each end, like of the lake, and you know your distance to each of those points. And usually that distance would be easy to measure, because if you're on land, you could just walk to one end of the lake and measure the distance without having to go in the water, and walk on land to the other side of the lake. So in this case, the surveyor measures the distance to the 2 points. In this case, it's not a lake, it's on each side of a house. And those distances are 50 feet and 70 feet. And just so there's no confusion, I'm just going to make this angle 75. I don't want to have 2 number 70s in the same problem. It's fine, but it might be more confusing. So let's make the angle 75 instead of 70. So that angle right here, that's the angle that the surveyor has to turn. If they're looking at a point on one side of the house, they've got to turn 75 degrees, and then they'll be looking at the point on the other side of the house. So we want to know how far apart are the 2 houses, or the 2 points on each side of the house, whatever it is. We're just trying to find the distance between 2 spots. In this case, I think it's the 2 points represent different houses. Now, you might think, well, just use a tape measure and measure the distance between the 2 houses. But we can't. Anybody know why we can't use a tape measure?
Didn't go that long.
It what?
They don't go that long.
Maybe it doesn't go that long. Maybe the 2 houses are like 10 miles apart. I don't know. They're really far apart. Well, in this case, the houses aren't that far apart. But there's some things between the houses that would interfere with our ability to use a tape measure. So there's the 2 houses. And here's the things that are going to mess us up. So we've got a giant crab. Stay away from it. Sometimes these things are like 6-7 feet across. They're pretty big. So we don't want to go near that. We got poisonous tree frogs. Those, we don't want that. And the worst thing, we got Easter Bunny. So we're going to be careful. We don't want to go between the 2 houses. So what we're going to do is we're going to use math. We're going to stay safe. So there's the 2 houses. And now, I didn't have a picture of a surveyor, but I had this guy. He's a soldier.
Is he holding a gun?
He might be. He's a trench soldier. I think from World War II, or maybe World War I. Oh, he's a soldier. Yeah. Or maybe it's a sword. I can't really tell. It's kind of hard to see. But yeah. All right. So that's what we're trying to figure out. So we've got the surveyor. We've got a couple lines we can draw in. Okay, we know the distance from the surveyor to house A. What do they tell us that is? The distance is 50 feet from the surveyor to house A. We also know the distance over to house B. They tell us that distance is 70 feet. And what's the one other number they tell us in the problem?
75 degrees.
And what's that?
Angle AB to ACB.
Angle ACB. ACB. 75 degrees. So the goal is to find out how far apart are the two houses. Okay, so we're going to find the distance between the two houses. Now, I don't know that distance right now, so what would be a good letter to call it? Yeah, I would use X. I know we normally use A, B, and C for the sides, but we've already used A, B, and C at other places in this word problem. So let's call this distance X. From there to there. Okay. So first thing, we've got a triangle, and we're just basically trying to find one side of it. We got to figure out if it's law of sines or cosines. Sorry, there shouldn't be a degree symbol there. What kind of triangle is that? Using the three letters.
Side angle side.
That is side angle side. Is that kind of problem law of sines or law of cosines? It's cosines, what we learned today. So our goal is to find x. And to find x, or to find any side in a side angle side problem, you always start out with that letter squared. X squared. Now, using the pattern in the law of cosines, anyone think they can tell me what would go on the right side?
Fifty squared plus 70 squared.
50 squared plus 70 squared. Yep.
Minus 50 times 70. 2 times 50 times 70.
2 times 50 times 70. Yep.
Cosine.
The cosine of the angle across from the side that we're trying to find, which is 75. So let's do all what we can, combine like terms, and then we're going to need the calculator to get the answer. Okay, so 5 squared is 25. 50, make it, put 2 zeros on it. 7 squared is 49, put 2 zeros. 2 times 50 is 100, times 70 is 7,000. And then that's multiplied by the cosine of 75. Okay, one more thing I can combine there before we put it in on the calculator. What's the last thing I can combine?
Can you square root it?
Well, we are going to square root it in a minute, but there's one more thing I want to combine that's going to go under the square root.
549.
Yep. What's 25 and 49 give us? So, yep, 7,400. And now the rest of it, we can't do anything else unless we round it, and we don't want to round it. Okay, so now we'll type all that in and see what we get. Now, looking at just reasonable numbers, remember what has to happen in a triangle. Any two sides added together have to be bigger than the third. So if I add 50 plus 70, how much do I get? 120. So that third side cannot be bigger than 120. If it is, you made a mistake. Okay? So square root of 7,400 minus 7,000 cosine 75. Same Looks good. So 74.755. So that is the distance between the two houses, and we stayed safe. Any question on that? All right, so that is the law of cosines. So let me put up the homework and the test topics. So the test tomorrow is on 4.2 and 4.3. So it's law of sines and law of cosines. Every type, all different types we learned. So we got angle, angle, side, angle, side, angle, side, side, angle, side, angle, side, 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 side. So there's 5 different types. The test will be probably 6 questions, so you'll see one of these types twice. Each type generally, unless it's a no solution, each type would have 3 answers. So that means if there's 6 questions with 3 answers each, it's going to be roughly 18 different answers.
Is there going to be a word problem?
I'll have to double check on that. I'll let you know. So any question on the topics on the test? Okay, so that the homework, that's on 274. It's those 6 questions, and we'll look at those to review before we do the test tomorrow.